Hello, college algebra. We're back, and today we're talking about day 4 from chapter 1. We're going to do some solving of things. And, basically this one is just getting us back into what if it's a different situation, making sure we don't fall into some traps and do some things that are not legal and get us the wrong answers. So, a lot of examples here. Today we're talking about a polynomial to start with. So I have 5x to the 4th equals 10x cubed. Now, that's a polynomial because the coefficients are real and the exponents are integers greater than 1. They're 1 and above, so they're the natural numbers there. So we have a polynomial. Now, the problem here is some people want to divide both sides by the 5 and the x cubed. The problem is we don't know what x is, and you might be dividing by 0. So instead of doing that, let's get all of this on the same side. So we have 5x to the 4th minus 10x cubed equals 0. Now we have the ability to go ahead and solve this and do some factoring so we have a polynomial where it's a multiplication, a product, will equal 0. Notice that both of these have a 5 and an x cubed in common. So 5x cubed they have in common. I'm thinking about that. We're putting the 5x cubed out in front. What's left here is just an x, and what's left there is a 2. Okay, so now we have a product of two things that equals 0. That means that either 5x cubed is 0 or x minus 2 is 0. This one telling me that x equals 2. This one telling me that x equals 0. Divided by 5, I can take its cube root. I still get 0. Then we can go back and check. Well, yeah, it makes sense. If it's 0, 0 equals 0. Check. If it's 2, that's a little bit more difficult here. 2 to the 4th, we're going to, squared is 4. Cubed is 8. To the 4th is 16. So we have 16 times 5. Okay, that's 0 carry the 3, that's going to be 80. And over here we have 10 times 2 cubed. Okay, so 10 times 2 cubed, that was 8. 10 times 8 is 80. Check. They both work on a check, and we have two solutions to that polynomial equation. And make sure we solve for that. All right, so that's example 1. Example 2. We'll turn up the heat just a little bit on this one. And in this example, we're going to, again, have some polynomial stuff here. And let's see what great, I better use the cheat sheet here to make sure I have a good one on this one. 2x cubed minus 8x plus 3x squared equals 12. Okay, equals 12. All right, I hope we learned, the first thing we learned here is, this is a polynomial because of the real numbers, but it equals 12 but not 0. So I want it to equal 0. Minus 12, little board magic here, equals 0. All right, now how would we go about solving this? Remember, I want to get a product equal to 0. So since I want a product equal to 0, I better try to make it I better factor this. And there's 4 terms, and when there's 4 terms, factoring we did factor by grouping. That's right. All right, so we're going to go ahead and group these first two. What do they have in common? They have a 2x. What's left over? After we've grouped the 2x, we have an x squared minus a 4. Plus, what do these have in common? A 3. What's left over? An x squared minus a 4. Well, Bob, I certainly hope those two things are the same, and they are! So we have 2x plus 3 times x squared minus 4 equaling 0. Now, remember, this can be broken down some more. So 2x plus 3, that can be factored into x plus 2 and x minus 2. And now we can see all of our answers. 2x plus 3 is 0. So 2x is negative 3. X is negative 3 halves. X plus 2 is 0. X is negative 2. And if x minus 2 is 0, then x equals 2. Here are my possible solutions. You know what you need to do? Go back and check all of those. This one, I would use the decimal for it. Go ahead and put those in there. Check, check, check. If they all work, there's my answers. Okay, for the sake of time, I'm assuming you guys can go back and check that. Okay, so there's some polynomials. We've done factoring because we took advantage of their product equaling 0. Okay, now on this next one, we're not so much going to take the idea that there's 0. In fact, we're going to do something very different on this one. We're going to have this x plus 1 over x minus 3 Notice we have a fraction here right away, so we don't have a polynomial. Minus 2 over x equals x times x minus 3, and what was I think that was a 12 there. Let me guess. Yep, okay, that's a 12. Okay, and so now we're going to say let's solve this. And this is what we might call a fractional, okay, problem. Because we have a fraction here, we have some fractions in it we want to solve. Well, when we do this, we'd like to have a common denominator. So I take a look at this and I say, okay, between these two, this has x minus 3, let's multiply this one, get a little spacing on that equal sign there, by the magic number 1. X minus 3 over x minus 3 is 1. Let's multiply this one by the magic number 1, x over x. Notice that this will give me a denominator. This will be x squared plus x. Big minus sign right here. Minus, and that's important because I need to make sure I distribute this. This is 2x minus 6, but that has to get distributed. And that was all divided by x times the quantity of x minus 3. Now that equals 12 over the quantity of x minus 3. Now we can cross multiply, but you'll notice that these two denominators are the same. And the only time we have a fraction equal to a fraction is if the numerators are the same. So let's take advantage of that, and we almost just kind of dissolve those two denominators, and we say, or you can think of multiplying both sides by it, and they cancel. So we know that when x squared plus x minus 2x plus 6, that's a common mistake, okay? Add 6 to it, equals 12. Now, if I can solve this, I should have my solutions. So I'll subtract the 12, add these two like terms, minus an x, minus 6 equals 0. Again, we're taking advantage of a product equaling 0, not the addition or subtraction, but I need a product. So this will happen when x minus 3 times x plus 2 equals 0, factoring. So when is x minus 3 0? When x is 3. When is x plus 2 0? When x equals negative 2. Hey, let's go ahead and check these, all right? Let's make sure that when x equals negative 2 will work. And so we'll say this is going to be, when it's negative 2 plus 1, I get negative 1 over negative 5 minus 2 over negative 2, and that should equal 12 over the product of negative 2 and negative 5. Okay, let's see. That's 1/5. This is plus 1, and that's 12 over 10. 6/5, wait a second, 5/5, 6/5, check. Woohoo! Okay, so I'm ready to box that one. Let's go back and check on x equals 3. 3 plus 1 is 4. Over 3 minus 3 is 0. Oh, no! What's happened? I'm dividing by 0. We can't divide by 0. Therefore, this is not really a solution. That's what we call an extraneous solution. Because when we have these fractions and you decide to multiply by x over x, who was saying that you weren't multiplying by 0, creating a problem here? The same thing here. We multiply by x minus 3 over x minus 3. You might have created a problem. So whenever you finish these problems, make sure you check your answer to see if they work. If they both work, they're both answers. If only one works, only one's the answer. If none of them work, there is no solutions. Maybe you want to check to make sure that you did it correctly if neither of them work, but you might want to graph it or take a look at it. In this case, x equals negative 2 is the only solution, and this was an extraneous, what we call an extraneous solution. So there is my solution to that fractional one. Okay? That's part 1 of the examples for day 4.